Howdy. Yes, it is a very cloudy sky at the moment. So there is absolutely no chance to see any auroras. But I think, in a way, that the brightness of the clouds here in the night is partially due to the auroras. Somehow it seems to shine through. It doesn't really come over on the picture, but it looks different than here on the picture. A few days ago, it somehow seemed that there could be auroras, despite there shouldn't have been. And I took a picture, and there hasn't been any. And I thought, yeah, okay. I wasn't really expecting it; just somehow looked like. And this was before we had the sequence of these X flares and stuff like that. So I really wasn't expecting any auroras. 1 hour later, we had auroras. And as you can see here in the picture, there has been clouds, almost not the whole day, but quite much clouds. And all of a sudden there was less clouds, and we had auroras. Not too much, but they were interesting in color. And not only were the auroras rather colorful, but also the fall. The fall. Or the leaves of the trees. Now let's just go through. There are a few nice pictures. And I'm somehow very amazed about the quality of the camera. That's amazing. A few years back, these kind of pictures, they would have required a very good camera. Nowadays, you just carry it in the pocket. That's mind-blowing. And from time to time, they even got a little bit more intense. And I don't know, could we call this orange auroras? Don't know. Maybe. There has been some talk about the orange-colored auroras in recent times. And obviously, if you use the wide lens, it doesn't really work. And that's just a lens flare, that's nothing. Then we had violet auroras and the cat. And obviously, triangles and stuff. Yeah, to me, that's very interesting. How is it possible that on one hill there are two churches and both of them have the same shape? Really? Yeah, there's like a lot of triangles. So it doesn't seem that the triangle thing is just a random theme. There has to be some reason for that. Yeah, that looked interesting. Like a beam just coming down. And it could also rather intense, but only for a very brief moment. And I don't even think that I captured the brightest moment of that. And also the band appeared between the clouds. And obviously you can see now we have already more clouds. Because there was a cloud cover approaching, so I knew that there isn't much time to see anything. And here's something going on the left side, and also the band on the right, with the approaching clouds. And then it just got more clouds, but still, the green was still visible. Not very easily with the bare eye, but anyway, visible. And these weren't visible with the naked eye. No chance. But they showed up in the picture. This bright one, of course, this was visible with the bare eye. But I'm not sure the one on the left, the green one, if that was visible. Of course, now this was visible easily. And that's also, like, on the one on the left looks interesting, because there is some color thing going on down there. Yeah, that's some interesting color. At least to me. I would maybe say that's orange if someone asks me, because we can compare to the leaves of the trees. Yeah, that's amazing. Yeah, obviously you understand we have to switch the phone around in order to get more of the sky and stuff, because yeah, it just doesn't fit into the picture. Yeah, and of course that's not every picture of them is good. That's straight up, I guess, more or less. I always try to get some trees into the picture in order for the camera to know, or that the camera has something to focus on. And that was very intense. I don't know if that's some digital remnant. I guess so. Maybe. Maybe not. I don't know. Would be interesting if it wouldn't be. And despite the faintness of the auroras, I'm very excited about the colors. There's a fair amount of colors. Yeah, that's a funny picture too. Yeah, they're not only green, there's also violet. No, it's not. Maybe there's some vortex structure in that as well visible. Yeah, I just noticed that's in a way like a time lapse. And then it was cloudy, but there was still between the clouds visible some auroras. Sometimes they were just like very faint, and sometimes rather strong. So this was easily visible with bare eye that there is something behind the clouds. So now we have watched some aurora pictures, and here are some pictures of rocks. You can see the layering of them. It's just continuing all over, basically to the other side. And many of these, they are rather smooth. You can see quartz veins all over the place. And then we had a halo, a double halo with sundogs. There's a sundog above, but there hasn't been really on the side. This is as wide as as I could take it. So you can see here on the side. No, maybe I have to make it. Let's zoom in a bit. Here, and on this side it's not really visible, but there is this brighter spot. And if the circumstances, environmental circumstances would have been better, they would have gone a line there and it would have spanned the whole sky over. But this time it didn't. But I just thought it was very nice to see that, especially with the one here on top. That's a nice one. So now let's go over to some reading, because we are about to enter Halloween time. We have a very strong geomagnetic storm going on. And I stumbled across some papers or some texts that were very interesting and related to what I have been talking about. So now let's go quickly first over to one of my papers where I talk about a little bit about Halloween. And from there we go on. So that's plate tectonic issues, the influence of electricity in rock forming processes, and the coherent connection between science, mythology, and history in part 3. They say that a little knowledge is a dangerous thing, but is not as half so bad as a lot of ignorance. Terry Pratchett. When we will dive straight into part 5 or chapter 5, cultural rituals and mythological stories revolving around Pete. So, cultural rituals and mythological stories revolving around Pete. That's my paper. The modern Western society has certain annual festivals. Some are tied to Christian beliefs, but some of pagan origin. Whatever the case may be, they all share one thing: they are heavily monetized. Their original meaning or purpose got lost a long time ago. The story got reinvented and changed to fit certain religious paradigms. This also functions as a wiping out of ancient knowledge for common people. A further tool to achieve a similar result is education. Uniformitarianism has its origins in England. It is the cradle of settled science on which mainstream science is based upon. Oxfordian science is very tightly connected to Christian beliefs. The origin of the peer review process also originates in England. It was invented to make sure the results of whatever scientific discovery don't give any possibility to question Christianity, the king, queen, or whatever else artificial authority. Still, as kids, we are awaiting Christmas time. In spring we celebrate Easter and occasionally other days off school because the church wants it to. The author hasn't been raised in any specific religious frame, and only because of certain rules of authorities, time in churches was spent. It always felt strange to participate in these rituals because they didn't seem to be from this world. Stories got told, rules explained, and ritualistic procedures were performed. Over time, the author learned, that there are also other religions. Later, it turned out that they fought with each other basically since the day they were founded, despite promoting that peace is the ultimate thing to achieve. For the author, or maybe better English to the author, I don't know, the amount of contradictions outerworldly stories and the rigorous defense system of each religion towards the others always posed a very big problem. It simply didn't make any sense. Discovering the electric universe with all the people and their works which were leading up to the point of where it is now opened a whole new way of looking at things. It is such a unifying theory that it seems too much for too many. There seems to be a deep-rooted fear to let go of old beliefs and embrace new ones. Almost no amount of contradictions is enough to let go. Rather believe in something that got taught in school as an absolute truth than in something which is understood and thought about. Let's take Halloween as an example of an ancient cult embraced by capitalism and maybe even kept alive by it. Many people don't really know what Halloween is about. So now I just wanted to show you something. Here we have reference number 1 and 2, and we are in chapter 5. So we go to chapter 5 in the references. Now let's do it like this. You can follow chapter 3. Then we have chapter 5. And I was talking about these, 1 and 2. And here we find Randall Carlson. So I know about his theory about Halloween. So many people don't really know what Halloween is about. 1 and 2 in the reference list. They know that at the time of the year, scary faces are carved into pumpkins and that there should be a candle burning in the pumpkin in order to make it visible in the dark. The only time of the year when you can see witches. But why? A scary pumpkin glowing in the dark? Witches? Most people never took the time to actually think about things like this. Too many don't even want to know, and they will have an excuse for it, which, after all, it could quite likely be rooted in fear. They lack the ability to be honest to themselves and admit that they were wrong, or the new knowledge would partially destroy their worldview. It is important to understand that the old knowledge doesn't go away. It will remain, and it can be processed in new, different ways. Once you start to see, you can't unsee it anymore because the forms and patterns, visual or literal, are omnipresent. As explained in part 2 of this paper, light phenomena in nature might have been much more common in ancient days, and very often they seem to be related to plasma. 50% of swamps in Finland are drained. And this number could be much higher, much bigger in other countries, maybe in Finland too, who knows. Considering water as a universal conductor and therefore as something very important for the energy to flow, we will have a chance to try to understand the importance of wetlands for the electrical environment. They are batteries. They provide energy for processes which include earth and heaven. Taking the water away will break the battery. Wetlands, peatlands, bogs, and such are considered mythical places, often misty, and going there can be dangerous. The ground might look stable, but it isn't, and the possibility of drowning in an unknown wetland is a real danger. In the past, several hundred years ago, wetlands were probably much more abundant than they are nowadays. This could mean that the overall charge in the environment was much bigger than it is today. Huge areas of wetlands were doing their thing They created such an environment of charge that they had their own microclimate. The net negative charge, possibly due to the acidity, created water vapor in the area and winds carried into regions with less water. Wetlands were not only important for themselves, but also for the surrounding areas. In other words, a dried up wetland will affect all the ecosystems surrounding it. When we think about the wetlands of the past, the huge amount of water they bore, we probably also understand that the energy confined and produced by such areas was by far bigger than it is nowadays. This is a very important point to recognize because the author, me, thinks that the jack-o'-lantern, the pumpkin, is a representation of plasma phenomena. They occurred in peatlands probably much more often than they do nowadays. It might be something similar to St. Elmo's fire, which was described by sailors. Their appearance must have been a rather frightening experience for the onlookers, especially when the lights emitted some sound. It is not known to the author if there has been any relation to solar activity, but it would only make sense. You know, if you would see this kind of light in a swamp and it would buzz, plasma sounds, I really wouldn't be surprised if it would be related to solar activity. It has to be. GICs, geomagnetically induced currents traveling through the crust, of which peatlands are part of. Yes, they are part of the crust. Could have charged the environment even more than usual. At a certain height above the ground, an atmospheric charge differential, geological features including metals or other conductive materials, and gas emissions from the moor created a brief accumulation of charge in the air, so much so that it started to glow. We call them plasmoids. There might be a very wide variety of plasmoids. Some of them probably burn cool. Plasma has different stages, and we might look at the phenomena which goes into the realm of glow mode. The position of those ominous lights in peatlands might in certain cases be almost the same. The author thinks that it has something to do with the geological setting, like the bedrock itself, which, as earlier explained, seems to form daisy chains reminiscent patterns. Other factors like temperature differences, amount of sunlight, moisture, content of the atmosphere and the ground, etc., will have effects on the occurrence of the lights. They might move around, hover up and down, and change size, shape, and color too. Something like a discharge upwards, as described in part 2. The streamers in figure 21 could probably also be expected. Yeah, I'm talking about the volcanoplasma phenomena where we have the streamers. We also need to recognize that depending on the atmospheric condition, hence gas mixture, it might not need very much of a current in order to get something ignited. In this case, we are looking more at something burning instead of glowing. The paper, Minimum Values of Voltage, Current, or Power for the Ignition of Fire, Vytenis Babrauskas, states, quote, "No electrical ignition will occur under conditions of zero voltage, current, power, or energy. Conversely, ignitions can occur when substantial amounts of voltage, current, power, or energy are available. This leads one to consider that there may be some lower limits for ignition to be possible. This is consistent with the general observation that for ignition to occur of substances which are not self-heating or exothermically reacting, some finite amount of external energy must be provided. There is no reason why the environment, which needs to be understood on all scales and as a whole, like Earth, Sun, Galaxy, and beyond, and not just locally Earth or even just a specific area, couldn't provide unprecedented amounts of energy. Considering this thought, we should expect these kinds of phenomena to ignite fires. But since they were presumably happening in wetlands, we could imagine that fires didn't spread very far, maybe just one burning bush. Nowadays, as we have so many dried out wetlands and the water level seems generally lower than back in the days, the possibility of underground fires ignited by induced currents, which are very hard to extinguish, is much higher. Also, common lightning strikes can ignite places which were formerly wetlands much easier. The effect of fuel-air mixture on the MIE for alkene series hydrocarbons, methane, butane, propane, ethane, hexane, and heptane. Combustible in air fraction of stoichiometric. Anyway, in this graph, as this graph shows, the amount of energy to ignite certain gases doesn't need much energy. The energy to make something glow might be even less. Considering also energy peaks in telluric currents, which could be understood as underground lightning, the possibility of fires breaking out many meters below the surface shouldn't come as a surprise. Yes, there has been many strange fires, for example, in the US. For example, Dutch Sins is talking about these strange fires that just break out in places. Yeah, I think they could be very easily ignited by telluric currents and stuff like that. But anyway, it is after all a similar mechanism which could have melted the ice and snow at the end of the last ice age. Yes. Let me read this again. And just a quick reminder, or like if you don't know, there seems to be some kind of a consensus or something like that, but it seems to be that the end of the last ice age came rather quickly. And I've been writing, I think, about this a little bit more somewhere in another paper. But the problem was, or like one of the problems that I somehow saw with the rapid end of the ice age is that the albedo effect of snow, it reflects the light back. If you have a white surface, the sunlight doesn't really do anything. You need a dark surface in order for the sunlight to do its thing, get stuff melted. So if there's a lot of ice and stuff, but the sun might shine or not shine, but if we have geomagnetic activity and there are induced currents into Earth, and we have all these peatlands and all that stuff that can obviously heat up rather easily and very quickly, we might get the answer to, or partial answer to the quick melting or ending of the last ice age. It is, after all, a similar mechanism which would have melted the ice and snow at the end of the last ice age. Induced energy travels underground and heats up the ground, taking into account that in many places there was a lot of water. Yeah, there was ice and snow. Rarely things ignited, nor could the fire spread very far. So, now we are talking about the. Now let's just a little bit still. Nonetheless, we have a charged environment and strongly fluctuating telluric currents, which easily can make stuff light up in different ways. The fact alone that there are several ways to have something glowing in the dark is a rather strong argument for an electrical explanation of the jack-o'-lantern phenomena. Okay. I have been talking now about the geomagnetically induced currents, GICs. And now let's go quickly to something very strongly related to GICs. And for this, we go to my YouTube channel. And there are two playlists here. They belong together, they are basically in a way the same. Let's go to this one here. And now just search for one of the videos. For example, this one. Let's put the volume down. No, there isn't any volume. That's a stone in the microwave. For those who haven't ever seen this, is some dust, but let's have a look at it. It has some very interesting inclusions, and it's yellow. And it has some quartz, and it's interesting. Interesting pebble. And I thought that, yeah, since there's yellow, there might be some iron inside, and let's see if it does anything if I put it in the microwave. And yes, it did. After some time, it started to do stuff. It started to glow. Now let's go a bit forward. Yeah, this happened to the pebble, to one of the pebbles I made in the microwave. There are several experiments. You can check them out on my channel. And in a way, one of the ideas I had when I first put a stone basically into the microwave was that, yeah, I replicate geomagnetically induced currents. In this case, it's in the microwave spectrum. Let's say the pebble is Earth and the power source is the sun. But it could easily be also the whole universe. So it's definitely scalable because the principle stays the same. And I have also this other video I made about my little trip to a laboratory, where I got the results from a Raman microscope about one of the melts of one of the stones. And we have very much aluminium. And for those who have an induction stove at home, you know we have to buy a special pan in order to use your induction stove. Otherwise it doesn't work. Why? Because it has to be a pan with an aluminium bottom. Because aluminium gets hot very easily. It reacts very easily to induced currents. Okay? So an induction stove isn't that, how to say? Yeah, it's a very good example for the same principle basically that goes on in the microwave. It's in a little bit a different way, but it is about the aluminium. And this is the melt that poured out of one of the stones, and it turned out it's approximately the same stuff that pours out of Icelandic volcanoes. So in a way, it is lava. The stuff that poured out of my stones as they melted in the microwave is lava. That's the chemical composition. You can make your own research, take a screenshot and go and compare to other lavas. All the lavas are a bit different, but there are probably 4 like main lavas or something, but many lavas seem to be very similar. I figured that out after I made some comparison of this chemical composition with things I thought could be similar. So now, that's my theory. Let's see if there's... Now let's just have a quick sneak peek into the video. We were watching the stuff with the Raman microscope. These are pictures. And then later on, he was preparing them in order to put it into an electron microscope. And this is part of the melt and part of the... These are 2 different stones. That's an electron microscope. Since we didn't have the time in order to prepare all the things, they were just put on that rig like this. And what I marked here, they should be prepared and they get put into these round holes and stuff like that. But it doesn't matter. I got the results. And despite I've been noodling about this for several weeks, because I went there with copper and sulfur in my mind and I came back with aluminium. You know, there's no sulfur, no copper. So I was baffled for a while. I thought, what's the thing? Until I figured out it's basically magma or lava. And I thought that's very interesting. That's why I also find it interesting that I observed those auroras before the Icelandic eruptions started. And all these kind of things. And if you know about my mountain water theory, that basically every mountain that where is water pouring out, or there's a glacier on top especially, is actually a volcano. Geothermal activity is volcanic in nature. So wherever you find geothermal activity, you have volcanic activity. And if you understand that very low geothermal activity, let's say the water is 0.1 degree, only very cold water, 0.1 degree is very cold water. It is very low geothermal potential, but it is geothermal potential. In other words, it is volcanic in nature. This is how I think, because it is either geothermal potential or it is not. If you go to Iceland and you have the hot springs, everybody, yeah, it's because of the volcanoes. If you have the flash flood coming from one of the volcanoes, yeah, it's the volcano melting the glacier from beneath, and that's that's where the water is coming from. Yeah, okay. You have hot springs in the Alps, yeah, but no volcanoes. No. You have flash floods coming from glaciers, no rain. Yeah, it's just glacier doing its thing, but no volcanoes. No, not here. Not one. There's no volcano in the Alps. That's just not. There's everything else. Sulfur springs, hot springs, flash floods, all these kind of things, glaciers, but no volcanoes, no. Probably they just once decided that there is not. So there is not. It's a consensus. They agreed. No, we don't. We don't grow volcanoes in Central Europe, in the Alps. We just don't. So, now we have been talking about geomagnetically induced currents, my microwave experiments that are in a way representing a similar thing. Geomagnetically induced currents, the pebble in the microwave is Earth and the microwave is the Sun or the universe. Stuff pouring out of the stones contains aluminium that is very susceptible to heat. And so it doesn't need much energy for the aluminium to get warm, in other words. And then, I haven't mentioned yet, but we were talking about clay. I tried to write something about clay. I didn't really manage too much to write about it. And yeah, because what we are looking at here is basically clay. In other words, many of the lavas the lavas that are pouring out of some volcanoes are basically clay. They are very brittle, and if you smash them into small, or if you break them, you can rub it between your fingers and it just turns into dust. And that's one of the pebbles that has been in the microwave that grew exponentially, but it turned out that it's hollow in the middle. There's a almost perfectly round bubble in the middle of this pebble. So if this pebble represents Earth in the microwave experiment, yeah, it is made of Earth. It's just a small part of Earth. It's just this pebble. But if it's able to create such a large bubble within a few minutes in the microwave, we must assume that Earth, the real Earth, might create similar bubbles too. When we have geomagnetically induced currents, for example, or let's use a yellow color, that's the center of Earth. This would be the plasmoid that would emit the heat rather unevenly in certain directions. That's why we have in some places many volcanoes and in some places not many, because we have the plates, as they are called. And the plates, they might just be here on the outer edge, and in the middle we have the plasma, and it's just growing. The transmutation of the element, there's the Birkeland currents, or the Birkeland current going through Earth. Where we have the plasmoid, and there is the transmutation of the elements going on. Probably there is aluminium created all the time, and water is created, and all that stuff is created all the time, but it tends to accumulate in certain parts, which is a very good thing. If this would be water and air, it would be on the other side, where we are. And that's why probably Earth is inhabited. So, Earth is creating its own elements. It seems to grow, sometimes in small steps, and sometimes it might have jumps in growth. They might be very heavily tied to solar activity. So, clay is lava, and it seems to be very abundant. At least what I've figured out, that there's a lot of clay on Earth. Many places, many mud volcanoes. Yeah. There's also mud flood theory. Yeah, this ties all very nicely into that. So now I just want to still read one paper. There would be so many other things, but I just wanted to share still one paper that ties many of these things I try now to explain about clay, aluminium, induced currents, and stuff like that into one thing. Maybe. Life Science, published 22 hours ago. Mysterious blobs in Earth's mantle are not what we thought, study claims. Lava that erupts from hot spots around the world seems to come from a similar ancestral magma, new research finds. Lava around the world may come from the same magma ancestor deep in Earth's middle layer, new research finds. Maybe it's just because of the aluminium, that's why it gets hot and melts. That's why it's so similar. And because the elements are accumulating into certain places. No, anyway, I tried to find a picture, but I didn't. So now let's go on with this paper. The study suggests that the deep mantle where magma rises is more uniform than scientists thought. Instead of being a stew-like mix of rock compositions, the mantle might be more like a blended smoothie, well mixed and similar throughout. It tells us that the mantle is probably much simpler than we were starting to think it is, said Matthias Schmidt, an earth scientist at the University of British Columbia. Structures observed deep inside the deep mantle may thus not be signs of different rock types, but rather temperature differences in the same kind of rocks. Smith said, the study examined hotspot lavas, which come from plumes that billow upward from Earth's deep mantle and erupt at volcanoes at the planet's surface. Samoa, Hawaii, and Iceland are all hotspots. The lavas that erupt at hotspots around the globe vary in their trace elements, which scientists have traditionally interpreted to mean that the mantle has lots of distinct reservoirs of different rock which don't mix or mix slowly, said Paul Tackley, a geophysicist at the ETH Zurich, yeah, who was not involved in the study. But large-scale computer models of the mantle suggest that this layer of Earth probably does mix efficiently. If that's the case, it's possible that magmas all start out the same in the lower mantle and differentiate as they rise through the upper mantle. We have 100 soups, Smith told Life Science. Do we make them from 100 different stock cubes, or do we actually have 100 different soups that we all made from the same stock cube? There is no way to peer into the lower mantle directly, but hotspots lavas do have chemical signatures that give hints of their history. Smith and his colleagues looked at lava concentrations of three elements: nickel, niobium, and chromium. Yes, I would have looked for aluminium. These elements behave differently as the melts rise and change on their way to the surface. Nickel tends to become incorporated into crystals. So liquid portions of the melt have lower and lower concentrations of nickel as the melt goes through more changes. Chromium does the same on a different timeline, while niobium tends to stay in the liquid. By looking at the proportions of these different elements, the researchers could tell which lavas had gone through the most changes from their original source and which were closer to the ancestral mantle magma. So now I just wanted to say one thing which somehow I just want to point out. Oh. There is no way to peer into the lower mantle. No way. And still, the most changes from the original source which were closer to that ancestral mind. How do they know? First, they say we have no idea because we cannot watch, we cannot go there, and now they are comparing their results to what is down below where they cannot go. I don't get it. In hotspot lavas around the world, the researchers team saw the same trends in these elements, and major similarities in the composition of lavas that had changed at least. The results indicated that lavas around the world are different not because they come from different stock, but because they change as they rise through varied rocks in the upper mantle and crust. All hotspots lavas point to the same starting composition, Smith said. Scientists still disagree about the composition of the deep mantle. There are odd structures near the core mantle boundary called large low shear velocity provinces, LLVPs, where seismic waves from earthquakes move unusually slowly. Some scientists have suggested these structures might be the remnants of ancient space rocks that hit Earth soon after it formed. Yeah, 17,000 billion years ago. Or perhaps that they are material from Earth's ancient crust, shoved deep by subducting tectonic plates. Let's go quickly to my paper still. Because metal inclusion. I have been talking about plate tectonics. Yeah, it's the title Plate Tectonic Issues, of course. Here are material or elemental distributions in certain geological formations. And I think they have to do with the electromagnetic wave because elements just accumulate according to their electromagnetic properties. And now about here it is. The author would like to express his admiration and respect towards engineers of all kinds because they are the ones making these kinds of discoveries possible in the first place. Figure 7. Thank you. This great technical achievement also reflects the impossibility of ancient people would have known about such mineral or metal occurrences. Still, their tales match the creation process of the geological features better than the prominent geological theory. Just think about the Revontulet, the foxfires, aka Aurora. The ancients knew about static electricity, at least. Results of modern day technology are amazing, no question. Being able to see giant fulgurites in the ground is even more amazing. These are ore occurrences in the ground made visible. And as you can see, we have vertical structures and almost vertical structures. Fulgurites probably did these. Yes, but I'll leave it here. I will put a link below to the paper. You can go and have a read there. Read the whole paper. And if you still have something to ask, ask. But it would be nice if you would take your time and read the paper first, because I just read a small part of the paper. There was many things I've been talking about earlier in the paper that are mentioned in the text. So there's no context to the thing or the things mentioned in the part I read. But it would be a very, very, very long video in order to explain all the things. I just hope you may have to make an account on academia. It doesn't cost anything in order for you to get paper. If you are not able to make it, write me a mail. I will send you a copy or something. But anyway, Halloween S3 solar proton storm, flares going on, storms, a lot of water, a lot of wind, and all the winds on Earth, more or less, are ionic in nature. They are spinning around some electromagnetic energy, let's say stream. That's why it's windy. Thanks.